Strombolian are more energetic. So these are getting a little, now we're getting a little more exciting, okay? They're low-level volcanic eruptions named after the Italian volcano Stromboli. Huh, there you go. That's why it gets, yeah. Ejection of an incandescent cinder, so you get cinder, lapilli, we talked about that already, lava bombs, to altitudes of tens to hundreds of meters. So you get 10 to 100 meters, not super high, but still pretty exciting. Small to medium volume, sporadic violence. Not a big deal. I mean, it's still a big deal. Every volcanic eruption is a big deal, but it's not as big as the ones coming up. All right. Then we get more exciting. These are the Volcanian ones. These are really getting exciting now. They are by a dense cloud of ash exploding from the crater and rising high above the peak. They commence with, you don't need to know about this, but this is a particular type of eruptions that can be extremely noisy due to the rising magma. They heat water to the ground. This is usually followed by explosive clearing of the vent, an eruption column that's dirty gray to black, and old weathered rocks are blasted out of that. So the volcano erupts, and we kind of create a new vent. And then the big guys are the Plinian ones. Plinian, if I can say that. Also, sometimes known as Vesuvian. Named after Mount Vesuvius in AD 79. They are marked by columns of gas extending high into the stratosphere, high layered to the atmosphere. The key characteristics are ejections of large amounts of pumice and very powerful continuous gas blast eruptions. These are Mount St. Helens, the big one everyone talks about, was a Plinian eruption. In fact, why don't we watch a quick video clip of Mount St. Helens erupting.
The eruption of Mount St. Helens in Washington State in 1980 occurred in much this same way. In a matter of seconds, much of Mount St. Helens was blown away, the mountain literally losing its top. Dense clouds of volcanic ash and debris poured out of a newly formed crater for days on end. Carried by the wind, the ash was blown hundreds of miles, burying towns and cities, turning day into night. The shots you are now looking at were photographed in mid-afternoon. The eruption leaves a ghostly wasteland. Trees toppled like matchsticks. Vehicles tossed about like toys. Crews were brought in to search for the dead and injured. All told, 62 people were killed. Forests and animal life were decimated. And at the mountain summit, a new crater nearly 2,000 feet across and 500 feet deep.
Wow, that was amazing, wasn't it? Yeah, cool. All right, now here is a table, the VEI, the Volcanic Explosivity Index table. You want to copy this down? You could print it too, All right, so they actually have a scale from 0 to 8. So 0 to skate. 0 is a Hawaiian, okay? These sometimes happen daily. Kilauea in Hawaii does this, okay? And then number 1 is a gentle. This is kind of a combination of Hawaiian and Strombolian. Also can happen daily, and this is also an example would be Stromboli himself. We get to number 2, and it's kind of a combination between a Stromboli and a Volcanian. And notice the plume height. This is how high the ash cloud gets up. And in 1992 we had one of these ball games. And then we get at number 3, severe, and that's a Volcanian. And this is Ruiz in 1985. And number 4, cataclysmic. It's a combination between Volcanic and Plinian. And then 1982, we had this particular volcano go off. And notice that the plume height gets higher. We're getting more exciting. And then we get number 5, and this is now a full Plinian one, and this is St. Helens in 81. And this happens every hundreds of years, every few hundred years. Number 6, colossal. We're getting very big. This is called, it's kind of a combination between Plinian and ultra Plinian. And Krakatau in 1883, that was one. That was a big deal. 25, greater than 25 kilometers. All these are greater, but they get very big. And super colossal and mega colossal, and you can kind of see this. And actually, notice the mega colossal example was Yellowstone. Yes, Yellowstone Park, which is in Wyoming, was a super volcano, and MA stands for millions of years. And when it went, boy, howdy lordy, it was a big deal. And you saw that actually in the activity, or you will see that in the activity as you do that. Okay. Another way to look at this is we can look at it graphically. We haven't really said this, but the volcanic explosivity index, I can't say that word, is actually logarithmic. That means it's a power of 10 scale. So this is how much volume is erupted, this many cubic kilometers, and every time you go up a scale, you actually go up by a factor of 10 times more. 10 times more, 10 times more. So, you know, between a 3 and a 4 is 10 times worse than a 3. A 5 is 10 times worse than a 4, which is 100 times worse than a 3 in terms of energy. And so you kind of see the idea. And Yellowstone ejected this much material, see the large red circle, where St. Helens was this much. And it's much difference. You can also look at it at a graphical scale. Again, this is that logarithmic scale. Even though this looks like a straight line, it increases. If you were to draw this, you algebra folks, it would really kind of go more like this. But they've changed they put this as powers of 10. And so St. Helens is down here, from a Plinian perspective, is not very strong compared to these other ones. So, yeah, kind of get the idea here. Okay, now, as I've just said, the increase in magnitude, a 0 is a 1, 10, 100, 1,000, 10,000. So if I wanted to compare that, every time you go up by a factor of 10. So it's pretty powerful how that all works. Okay, one last thing. We didn't say this earlier, but airplanes have issues with volcanoes because they use the air. If an airplane goes through a volcano, the ash cloud of a volcano, it'll probably go down. All right. And so the aviation color code used by the USGS volcano observatories, this helps us to understand when you got an issue. And they have yeah, so green, not a big deal. Yellow, orange, red. Probably what would be good if you copied this down or printed it up or whatever. You can kind of see. This is probably, there's a red index in the Philippines as we speak because they believe an eruption is imminent with significant emission of volcanic ash. And so it's underway or very suspected, and so they probably have a red thing in the Philippines as we speak because of that. If I can, I'll stop the podcast, but if I can, I'll find a short clip of today's news here on, by the way, I'm making this on December, I don't know what is today, 17th, 16th? I think it's the 17th of 2009, and so we have some excitement happening in the world of volcanoes as we speak. Okay, and this is another one, the alert normal advisory watch warning. All right, this is so if you live near volcanoes, so when St. Helens was about to go and they had a warning as opposed to normal, hey, it's not doing a whole lot. So yeah, copy that down as well. Okay, I think we're done. So we will see you in class. Bye.